Miscellaneous exercise 10. Question number 1. Here we are given a line in the form of ax plus by plus c equals to 0. The first sub question is, if the line is parallel to x-axis, get the value of k. Line is parallel to which axis? X-axis. Parallel to x-axis. So what we'll do here? If you just recall the theory, if you have any line parallel to x-axis, your line L, then x variable must be absent. That means the coefficient of x must be 0. So small a must be 0. That means k minus 3 must be 0. So we have k equals to 3. Right? I repeat, if you have line parallel to x-axis, then x variable must be absent. X variable is absent. If x variable is absent, then its coefficient must be 0. Variable never be 0. Fine. So k minus 3 must be 0. Second question. What's the second question? Parallel to y-axis. Parallel to y-axis. So same thing. It's vertical line like this. Parallel to y-axis. So y variable must be absent. That means coefficient of y must be 0. Okay. Here b is 0. Coefficient y means b is 0. And therefore you have k square equals to 4. And therefore k equals to plus or minus 2. These are the values of k. Third sub question. What is third sub question? Line passing through origin. Okay. So if you have line like this, ax plus by plus c equals to 0. If it passes through origin, then it must satisfy this equation. 0, 0 must satisfy this equation. This is 0, this is 0, therefore c must be 0. Right? This is always true. What? Keep in your mind, this we are not used earlier. If line passes through the origin, then the coefficient, that constant c must be 0. Passing through the origin, passing through your 0, 0. So what we'll get here? K square minus 7k plus 6 equals to 0. Factorize this. What are the factor? K minus 6, k minus 1. This is obvious. So either k is 1 or k is 6. These are the values of k if the line passes through origin. Either 1 or 6. Okay. Next question. Question number 2. Find the values of theta and that small p if the equation is in the normal form of the line this one. Okay. So we had such questions. I think we had done 2 such sub questions earlier. Okay, so here line is like this. Root 3x plus y plus 2 equals to 0. What you want to do? You want to express in that form. Which form? P theta form. X cos theta plus y sin theta equals to small p. What you need to keep in your mind? The constant should be positive. Number 1. Okay, so I'll keep this 2 over here. I'll take these 2 terms on the other side. So it is this. This should be positive. Okay. This should be positive. You cannot keep minus 2 on this side. Now, what is one more important thing you need to observe? The coefficient of x, that is cos square theta, coefficient of y, which is sin square theta, with root, this should be 1. That is the observation. Here you see what is the coefficient of x, the whole square, 3 plus 1. So this is 2. This is not 1. It should be 1. So how do I get 1? Dividing above equation by 2. Dividing by 2 on both the sides. Why? Why we are dividing by 2? It should be clear to you. Coefficients squares with the square root should be 1. That is observation here. But in this question it is not. So we divide by 2. So minus root 3 by 2x minus 1 by 2y equals to 1. Now you can check 3 by 4 plus 1 by 4 gives us 1. So it is in this forms. Now compare with this. If you compare with the given equation, cos theta is minus root 3 by 2. And what is sin theta? Minus 1 by 2. Okay. Clear? Just comparing with what? Just comparing with given equation. We have compared with this. So P is obviously what small p? That is here 1. So small p you have obtained. Now what about the theta from this? What is theta from this? Your angle is in which quadrant? Angle is in which quadrant here? Third quadrant. Okay. Angle is in third quadrant. Get the theta for which cos theta is root 3 by 2 and sin theta is 1 by 2. So it is pi by 6. To which quadrant? Third quadrant. So here you have pi. So it is pi plus something. So you have 7 pi by 6. So this is angle theta and this is small p. Okay, can be asked in MCQ or in subjective also. Okay, let's see the next question. Question number 3, third question here. This question number 2 is similar to, if you, just for your reference, exercise 10.3, question number 3, right? We had 3 sub questions there, so just refer this. Question number 3 is from exercise 10.2. There you had question number 12 and 13. Both were important. This is also important. So here this question talks about what? Two intercepts. Find the equation of the line which cuts off intercepts on the axis whose summation is this and the product is this. Okay, so we use this form, you know, x upon a plus y upon b equals to 1. Okay, call this as equation number 1. Now what is given here? You are given two things. What you want to do in the solution? We get the values of a and b from the condition and we'll place in this main equation 1. That's all in all about the solution. I repeat, what we'll do? We get the values of a and b from the given conditions. We get the values of a and b, we place in the equation number 1. What are the conditions here? The summation is 1, that is a plus b is 1. This is one equation. And what about the product? The product a into b is minus 6. Now, what is all in all about the solution? With the help of small 1 and small 2, you solve these two equations. Get the values of a and b and place in the equation number 1. So I'll write solving 1 and 2. How do we solve the 1 and 2? Get the b from this. Put into that equation. So a as it is. What is b from this? Minus 6 by a. b minus 6 by a plus 1. Not plus 1, equals to 1. Just we got the b from this. Minus 6 by a. What is b from this? Minus 6 by a. From this and placing this. Now we just simplify. So here we have a square minus 6 equals to 6a. So a square minus 6a minus 6 equals to 0. Factorization. Okay. So we just need to factorize this here. Sorry, this is my mistake. This should be just a. So here we have a. Now we factorize a minus 3 into your a plus 2 equals to 0. This will be the factor. So either a is 3 or a is minus 2. If a is 3, then what about b? Product should be minus 6. So here this should be minus 2. So one possibility is this. And here if a is 3, then a is minus 2, then b should be 3. Why b should be 3? Because product should be minus 6. Or summation should be 1. Here sum is 1, sum is 1. Okay. Now we put these values in the equation number 1. So by 1, just place the value, get the required line. Here by 1, just place the value. So you will get the required line. Fourth question. What are the points on the y-axis whose distance from the line? So you are given a line here, which is x by 3 plus y by 4 equals to 1, which you can rewrite as 4x plus 3y here minus 12 equals to 0. This is a given line. You want the point on the y-axis. So let point be. How do we select the point on the y-axis? On the y-axis, x coordinate is 0, 0 comma y on y-axis, right? We had exactly same question in previous exercise. You can just refer it. Exercise 10.3, question number 5, fifth question. That was about x-axis. So we had chosen x comma 0. So you have point. This is like x1, y1. Okay. You have a line here. Now what is given to you in this question? What's given to us in this question? Distance equals to how much? 4 units. So here p equals to 4 units. And you want to get coordinates of the point p. That means just you want to get the y here. Okay. So we use that formula. Small p equals to which formula? Modulus of ax1 plus by1 plus c upon under root a square plus b square. What is small p? That is 4. In this equation, instead of x you write 0, instead of y we write y. So 0 plus 3y minus 12 upon root of a square plus b square, that is 16 plus 9, which is 25. Okay, so what we'll get from this? Further, if we simplify, this is just 5. So here we have 20. This is equals to, you have modulus of 3y minus 12. Now you have two possibilities. 20 equals to 3y minus 12, or minus 20 equals to 3y minus 12. Okay, get the y and you write the final answer of p of that 1y or p of 0 comma the second y. There are two possibilities for the point p. Why we have two possibilities? Why we have two possibilities? Because we have here modulus. Okay. The fifth question. Find the perpendicular distance from the origin to the line joining these 2 points. So we are given these 2 points. So what we'll do? First we'll get the lines through these 2 points. So we'll use that 2-point form. This is like x1, y1. This is like x2, y2. Okay. So equation of the line here, equation of the line, if you just recall, y minus y1 equals to here slope into x minus x1. This is slope. Okay. Slope you can find very easily from the given 2 points. So we just place the values here. So therefore y minus y1, what is y1 here? Sine theta equals to slope y2 minus y1 upon x2 minus x1. So we have sine phi minus sine theta upon we have cos phi minus cos phi minus here cos theta. Okay, I repeat, I think there's a mistake. Cos theta minus cos theta comma sine theta cos phi comma sine phi, y2 minus y1 upon x2 minus x1. Okay, this is fine, into x minus x1. What is x1? That is cos theta. Okay, now you need to express in which form to get that perpendicular distance. It should be in this form, ax plus by plus c equals to 0 form, general form. The line should be always expressed in this form. Okay, so we simplify this further. Here y into cos phi minus cos theta minus sin theta into cos phi minus cos theta, that is equals to here sin phi minus sin theta into x minus cos theta into sin phi minus sine theta. Okay, we are just simplifying. This expression is multiplied with this sine theta into this expression into x, and this expression into cos theta. Okay, now I'll take this expression over there, this one. So this one I'll keep as it is, sine phi minus sine theta into x. This one I'm taking on the other side. Okay, so here what you have, if I take on the other side, you have, if I take on the other side, you have minus sine minus, let me write here, cos phi minus cos theta into y, and this one I'll take on that side. So here, or you can write plus form, I'll take that one over there. So plus, here this will be plus sine theta into cos phi minus cos theta minus cos theta into sine phi plus cos theta into sine theta. I open the bracket here. This I forgot to open, but will open in the next step, equals to 0. I hope this is clear to you. This much is as it is. This I've taken on this side, so minus. This I've taken on the right hand side, so this will be plus. What about this? I open the bracket here. Cos theta sine phi minus minus will be plus cos theta sine theta. Okay, one more step here of the simplification. Sine phi minus sine theta into x minus cos phi minus cos theta into y. What about this if I open the bracket? This is sine theta cos phi minus sine theta into cos theta minus cos theta into sine phi plus cos theta into sine theta equals to 0. Okay, now this will get cancelled. You can see that this is one known addition formula, right? Sin x cos y minus cos x sin y. So not these two, I'm sorry, these two will get cancelled. Here you have theta and phi. So this one as it is, this one also as it is. Okay, one more step. So sin phi minus sin theta into x minus cos phi minus cos theta into y. Now what about this? If you look at these two remaining terms, look at these two remaining terms. What is this? This is sin x cos y minus cos x sin y. So it's a addition formula for sin x minus y, that is theta minus phi equals to 0. Fine. Recall the addition formula of sin x minus y. Sin x cos y minus cos x sin y. So now it is in the form of, you can see ax plus by plus c equals to 0. That's the line through given 2 points. Now we find the perpendicular distance from the origin. What is asked? Perpendicular distance from the origin. Okay, so let me write on the next. So here, therefore, perpendicular distance from origin, that is equals to, there in place of x you are going to place 0 here. This is 0, this is 0, we are left with this much only. Modulus of sine theta minus phi upon root of coefficient of x the whole square, which is sine theta minus sine phi the whole square plus cos phi here minus cos theta the whole square, right? Which formula you have used? The perpendicular distance from the origin, indirectly this formula, modulus c upon under root a square plus b square. You have used this formula. Now the question is just simplification. We'll keep right now that numerator expression as it is, that is, theta minus 5 here, this one as it is with modulus upon, here we expand both the brackets. Let's expand both the bracket. So sine square theta, from these you will get the cos square theta, which is 1, plus sine square phi cos square phi, this is also 1. If you just expand, we have just middle term here, minus 2 sine theta into sine phi. What's the middle term here? Minus 2 cos theta into cos phi, right? Expanding by which formula? Expanding by a minus b the whole square. Sine square plus cos square, that is 1. Sine square plus cos square, that is 1. We wrote just middle term here. So this is nothing but the sine theta minus phi here upon, what about this? This gives us 2. Take minus 2 common. If I take minus 2 common here, what will get? Sine theta sine phi cos theta cos phi. It is just the formula of cos x minus y, because middle sign is your minus. So it is cos theta, you have plus, so here you have minus. Fine, right? Which formula? Cos x minus y. What is cos x minus y? You know, cos x cos y plus sin x sin y, addition formula. Once I take minus common, then cos x cos y plus sin x sin y. So we have this. Okay. You can keep just 2 common inside the square root. So if I take 2 common here, we'll get the 1 minus cos theta minus phi. Now this is also a known expression. So again, modulus of this one as it is, modulus of this expression as it is upon here. What about this? This is also one standard formula from trigo. Just recall sine square x by 2. So it is 1 minus double angle, which is cos x by 2. If you are minus, then sine square. If you are plus, then cos square, which you know very well. So here this 2 will go that side. 2 into sine square and half of this angle, that is theta minus 5 by 2. Okay? And therefore, now finally, this is your last step. Modulus of sine theta minus phi upon that square and square root will get cancelled, so we'll get the modulus. This is just 2, and this is sine theta minus phi by 2. This is required perpendicular distance. Okay, we have used trigo effectively here. What's the perpendicular distance here from the origin? That is sine theta minus phi. You can write phi minus theta also. That's not important because you have modulus upon 2 times sine theta minus phi by 2. You can interchange this because you have modulus. Fine. So simplification is very important in this. Question number 6. You are given 2 lines, 1 and 2. You have asked a line through intersection of these 2. So we get their intersection points, this one. Okay, this is line, one line L1, say the other line L2. You have these 2 lines. How do you get this intersection point? By solving these 2 equations. So we solve these 2 equations. So you're solving equations 1 and 2 by elimination method. Okay, so let's solve these 2. I'll solve this. I'll multiply first equation with 3. You know elimination. So 3x minus 21y plus 15 equals to 0. And 3x plus y equals to 0. Just we change the sign here. So this will get cancelled. This is minus 22y plus 15 equals to 0. So therefore y is equals to 15 by 22. That is 1. Now we put the value of y in any one of these 2. So we can put into the second one. So by 2, here 3x equals to minus y, that is 15 by 2 here. So what is x from this? X will be here obviously minus y by 22. So what is the point of intersection? So point of intersection equals to x comma y, that is minus 5 by 22 comma 15 by 22. This is point of intersection. This is x, and here this is y. Okay, so this point. Now you know line is parallel to which axis? Here, y axis. So y coordinate must be absent. So you know the equation here. So equation of the required line. Required line means line parallel to y axis. X equals to constant minus 15 by 22. So you can write 22x plus 5 equals to 0. This is the required line. What is asked? Line parallel to y-axis. This is your line, required line. So it must be x equals to some constant. Y variable is absent. Vertical line. One of the standard form. Any line parallel to y-axis is given by what here? X equals to constant. So you have this. Okay. The next question number 7. Find the equation of a line drawn perpendicular to this line through the point where it meets the y-axis. Okay, so here you are given this line. I'll just express in ax plus by plus c equals to 0 form. So I'll take the 12 as the LCM here. So this is 3x plus 2y minus 12 equals to 0. Okay, just we have expressed in which form? Ax plus by plus c equals to 0. Okay, now you need a line which is perpendicular to this, so slope can be obtained, and the point where this line intersect the y-axis. Okay, so let's write the slope of this line first. What's the slope of this line? Minus a by b, so minus 3 by 2. So therefore slope of required line, you know, slope of required line equals to reciprocal with opposite sign. Which concept you have used? m1 m2 equals to minus 1. m1 m2 equals to minus 1. That concept you have used. Slope of the required line is 2 by 3. Now how do we get the point? Slope you have obtained. The point is nothing but the point where these intersect the y-axis, right? So I'll write line 1 intersect which axis? Intersect y-axis. So put x equals to 0 there. Whenever line intersect the y-axis here, then the x coordinate is always 0. So I'll put x equals to 0. So you get the 2y minus 12 equals to 0. And therefore y equals to 6. And therefore the point will be this. Which point here? 0, 6. Indirectly this is y-intercept. This is just by putting x equals to 0. Okay, so this is the point where this line intersect the y-axis, and the slope of the required line is 2 by 3. Point slope. So you can use which form? Point slope form. So therefore you can write required line is y minus y1, that is 6, equals to slope. What's the slope here? 2 by 3 into x minus x1, which is here 0. This is like x0 y0. This is slope. So we have 3y minus 18 equals to 2x. And therefore finally what we'll get, if you just rewrite, it will be 2x minus 3y plus 18 equals to 0. This is required equation, right? I repeat, see, first you got the slope, therefore the slope is this, using this concept. Now given line intersect the y-axis, it's given in the question itself. Find the line, the point where this line must intersect the y-axis. So to get the coordinates of y, we just put x equals to 0. So this is the point, this is the slope. And using point slope form, you have this equation. Okay, next question, question number 8. Such questions you might have done probably in 10th standard in 8th question here. Find the area of a triangle formed by these 3 lines. Okay, here you are not given the vertices or the coordinates of the vertices of this triangle. Instead of that, you are given just equations of the 3 sides. Okay, so you have this triangle here. So triangle ABC. Okay, in triangle ABC you are given equations of the 3 sides. Okay, so I'll write like this. Let the equation of the side AB, this side, for example, this side is given by y minus x equals to 0, 1. Side BC is given by x plus y equals to 0, and side AC is given by this side AC is given by x minus k equals to 0. Okay, what we want to do to get the area of a triangle, you need the three vertices, coordinates of these three vertices. How do we get A? You can see by solving 1 and 3. How do we get the B? By solving B is here 1 and 2. By how do we get the C? By solving this 2. So I'll write, for example, 3 equations you need to solving 1 and 2. So we'll get, which is common point here? B. So we'll get the B. We get B. You can see that the common point is B. Here we get the B. Elimination is very simple, just to add them. So 2y equals to 0. X will get cancelled. Therefore y is 0. If y is 0, x is also 0. And therefore b is 0, 0. So you got the 1 point. Okay. Then suppose I want C. So what I should write? Solving, where is C? Common in these two? 2 and 3. We solve this 2. Solving second and third. So common is C. Okay, so we get here, we get point C. Fine. Okay. So you know here x equals to k by 2. Okay, x is k. You put there in the other equation. So y is minus k. So therefore C will be k comma minus k. Your final answer will be in form of what? Small k. Your final answer will be in form of what? Small k here, because coordinates are in form of k. Okay, chalo then one more. That is, you want now which coordinate? A. A is common where? In this 1 and 3. So you write solving 1 and 3. So what we'll get from this? We get A from this. We get A from this. Okay. So here also you can see, if I solve 1 and 3, you will get A, because this is a common point. X equals to k. Here x is k. If x is k, put there. So we'll get the y equals to x, and therefore y is also k. So therefore here A will be k comma k. Minus k and 0, 0. And now you can do as we did earlier. You know how to get the area of triangle. Area of triangle ABC, that is equals to, how do we get? You have that prepared formula, half in that modulus expression. Just place the value. You can take this is like x1 y1, this is like x2 y2. You can choose anything. The choice is not important. And this is like x3 y3. Right? You know that formula, x1 into this, then that x2 into this, and so on. You have that prepared formula. Just place the value and simplify. Okay, so you will get the required area. I'm sure this much you can do. The only important point was how to get the coordinates of the vertices of this triangle. So try it. Just you need to place into that expression. Okay, let's go to next question. Ninth question. 9th and 10th have similar question. You are given 3 lines. You are asked to find the value of small p here such that the lines intersect at one point. So what we'll do, this is in fact the question about concurrent lines. You know from geometry 1 with my concurrent lines. Concurrent lines means what? 3 lines intersect at exactly one point. Like this. Such lines are called concurrent lines. So what we'll do, we take any 2 out of these 3, we get this intersection point, and if they passes through exactly one point, third point will also pass through the same point. Third line will also pass through the same point. Let me call this as 1, this is 2. We solve these 2 equations because they are free from p. You can take any 2, that's not important. Solving 1 and 2. So we get this intersection point. Let's solve these 2 equations by elimination method. So just to add them, so y will get cancelled. So 5x minus 5y equals to 0. I've just added these 2 equations. So x is 1. Put this 1 in any one of these two equations. So for example, by 1, here you have 3 plus y minus 2 equals to 0. Okay. So if I put 1 in the first equation, you have 3 plus y minus 2 equals to 0. And therefore y is minus 1. And therefore intersection point is here. Intersection point equals to 1 comma minus 1, this point. 1 comma minus 1 of the two lines, this one. Now if 3 lines passes through one point, then third line will also pass through the same point. So this point must satisfy the equation of the third line. Okay. Now I'll write as 3 lines passes through the same point, 1 comma minus 1. That means the coordinates of this point, I'll write here 1 comma minus 1, satisfy equation, third equation, which is a third equation which we have not used so far. Px plus 2y minus 3 equals to 0. So you'll get the p into 1 plus 2 into minus 1 minus 3 equals to 0. So therefore p equals to how much? 5. That's the required value of constant p. What we have used? Concept, that is, we have used these two lines, we got the intersection point. If these 3 lines passes through exactly one point, then third line will also pass through the same point. So it will satisfy the equation. And from there we got this value of p. 10th question, which is just copy of the previous question. You are given 3 lines. Y is equal to m1x plus c1. Y equals to m2x plus c2. And y equals to m3x plus c3. How many lines you are given? 3 lines. Okay. What we do? We use these 2 lines. We get their intersection point by solving these two. X will be very easy. Just compare these two. So we'll get the x immediately. Y will be compared here. So x can be obtained very easily. Put value of x in any one of these two. So we'll get the y. So this is the intersection point. Now these 3 lines intersect in exactly one point, as I explained in the previous case. Then this will satisfy this equation. So instead of y, you put here m3 as it is. Instead of x, you put here plus c3 and simplify. So we'll get the required expression. That's all in all about the solution. Concept is from the previous solution. Use these 2 equations, solve them. So we'll get the x and y, that's the intersection point. If these 3 lines intersect in exactly one point, then intersection point of the previous 2 lines must satisfy the third line. So that x coordinate you are going to place here, y coordinate you are going to place here, and simplify. So you will get that required expression which is asked to show, right? So do it.